In this lecture, I'll cover the lens maker formula. And in lens maker formula, basically, I'll derive the full formula. You have to identify four triangles. There is no random thing there that which triangle I'll pick. Basically, you have to use exterior angle is equal to sum of the interior angle in four triangles, and your job is done. Which four triangles you have to choose? You have to choose four triangles which relate to the line which is the radius. For one surface, there are two radius. For the surface one, there will be one radius, and for surface two, there is another radius. These radius are the lines which will give you the cue which triangle you have to choose. Now let us start. Always when you draw the lens maker formula diagram, try to draw the bigger things on a larger scale because it becomes very clumsy. Take this image point at some good distance. So let this be A. Draw the incoming ray, and here draw a normal to this first surface. This is normal to the first surface, and I draw by dotted line, and this line is also going to be important in deciding my two triangles. This should fall in two triangles which I have to pick. Now this is I1 and this one will be R1. This is R1. Here when it strikes the second surface, draw another radius vector. It comes here. Draw an extended imaginary straight line. Had the second surface not been there, it would have gone straight. Now this is your I2, and also draw now the refracted ray. Refracted ray will be like this here, and if you see, this is your normal, so this angle is your R2, and this is basically opposite angle, so it is I2. So here just be careful when you draw R2 and I2. Write this equation, write N1, N2 and N1. All angles are small, so sine I equal to I, tan alpha will be alpha, whatever angle I'll take, so all angles are small. That is another assumption. And one more assumption is that these heights I will take equal. Whenever I write these heights, I'll write simply h. So these are some assumptions. Now Snell's law formula, n1 sine I1 is equal to n2 sine R1, and sine I1 I will write as I1, so n1 I1 is equal to n2 R1. That is one formula you write. Then write for this surface, n2 I2 is equal to n1 R2. So this is done. Now second stage, start marking A, B, C, D, E, F, G. Follow this pattern when you practice it. It helps in memorizing things also. Mark this as alpha, beta, this is gamma, this is delta, and let this be lambda. Also follow a pattern here. Whatever angles you may choose, mark some angles. Right now tan alpha is approximately alpha, which will be equal to h upon Ca. H upon Ca. I am writing all heights as h here. Both sides it is h equal. Tan beta is how much? Is beta, and this will be, when you write for beta, this is the triangle. It is reaching here. So you take this triangle. So h upon db. H upon db. Now write tan gamma. Tan gamma is equal to, for gamma, h upon ce. These small distances are ignored. These small distances, this and this. So these are just ignored. Then tan lambda is lambda, and tan lambda will be h, will be this h upon df. Now tan delta and tan lambda will be h upon dg. This was delta, sorry. Tan lambda will be h upon dg. Now you've written this. Now next stage you have to identify 4 triangles. First identify 2 triangles for surface 1, and this is surface 2. What is the radius for surface 1? This is the radius for surface 2. Pick this line and see 2 triangles where this line exists. If this is H point and this is I point, see 2 triangles where this line is there. So it is AHE. AHE is one triangle. Another triangle can be EHG. That is only triangle EHG. So these 2 triangles, so no confusion how to pick triangles. Pick this line for the first surface, radius, and see what are the 2 triangles which contain it. I have written. Now write the interior exterior angle. I1 is equal to, for this triangle, alpha plus gamma. For this triangle, what is the exterior angle for this bigger triangle, whole triangle? Gamma is the exterior angle, gamma. Interior angle is R1 and lambda, R1 plus lambda. And write R1 as gamma minus lambda. Multiply this by N1 and this by N2. Since N1 I1 is N2 R1, so I get N1 alpha plus N1 gamma is equal to N2 gamma minus N2 lambda. So I get N1 alpha plus N2 lambda is N2 minus N1 into gamma. Take the gamma on one side. Gamma pertains to the radius. So take that on one side. So this equation is done. If you want, you can write now angles also. So H is common, I'll cancel straight away. N1 upon alpha is, I'll write CA plus N2 is DG, and this is N2 minus N1. What is gamma is CE. Now suppose I want to stop here and I want lens maker formula only for this surface, first surface. So if I stop here, though I'm not stopping, suppose I stop here, I cover only the first surface. For first surface N1, the CA is my U, and I am measuring the incoming rays like this. I am measuring in this direction from this surface. So it will be minus U plus N2 upon, for first surface, this is my V, DG is my V. So it is positive, it is going along the incoming ray, and it is N2 minus N1 upon what is CE. CE is my R. For this surface, CE is my R and it is positive, so I write R. This is a very important formula. N2 upon V minus N1 upon U is N2 minus N1 upon R. Putting proper signs, you can solve any problem on single surface. Now coming back, this I have done. Now my job is just almost done. See this line for surface 2, this is my radius, and find out 2 triangles where this is there. So 2 triangles will be, one will be B, I and F. B, I and F is one. Another is B, I and G. B, I and G is the other triangle. What is the exterior angle for B, I and F? The exterior angle, if I write, if I extend it like this whole angle is R2. So for this triangle, I write R2 is equal to beta plus, it is BIF, so it is lambda. Beta plus delta, beta plus delta, and this was R2. Now for B, I and G, my exterior angle is I2 is equal to beta plus lambda. Multiply N2 I2 is N1 R2. So you will get N1 beta plus lambda is equal to N2 beta plus, it is delta, it is lambda, Now I rearrange it. N1 beta plus N1 lambda is equal to delta is equal to N2 beta plus N2 lambda. Now, which is my radius? Which angle pertains to my radius is beta. Take beta on one side. So n1 lambda minus delta minus n2 lambda is n2 minus n1 into beta. I get like this. Now put the value of what is delta. Delta is n1 upon delta is df minus n2. What is lambda? Lambda is dg. Here don't put the sign, I am putting the trigonometric values, not the optics values. N2 minus N1. What is beta? Is dB. Now add these two equations. This will get cancelled. So you get finally N1, or let me write here, N1 upon Ca plus N1 upon dF is equal to N2 minus N1 1 upon Ce plus 1 upon dB. Now put the optics values with this sign. What is Ca? Ca, this is the incoming ray, Ca is minus U. What is dF? dF is image V and it is positive. It is along the incoming ray. This is the direction. I'm coming like this. Here I was measuring opposite, so negative. Here I'm going along, it is positive. Now what is Ce? Ce is for the surface one, it is R1 and it is positive. I am going in that direction. So is R1. What is dB? dB is this, is R2 and I am coming opposite direction to this. So it is minus R2. So I write here N1 upon minus U plus N1 upon V is equal to N2 minus N1 Ce 1 upon R1 minus 1 upon R2, which is your length maker formula. 1 upon V minus 1 upon U is N2 minus N1 upon N1, 1 upon R1 minus 1 upon R2. So just by following those set sequence of methods, I have arrived at that formula. Be careful when you use it. Again, now when you put the values, you can use it for convex, for concave, for anything. Only thing is you have to take care of sign. Suppose